Picture this. You're standing on the deck of a merchant ship in the middle of the North Atlantic. It's March 1943, and the ocean stretches endlessly in every direction. 41 ships surround you, all carrying supplies that could mean the difference between Britain's survival and surrender. But here's what keeps you awake at night. Somewhere beneath these waves, German submarines are listening. Not searching, not guessing, listening. And every turn of your propeller, every rumble of your engine, every vibration of your hull is screaming your exact position to an enemy you can't see. Now imagine that the man who's about to solve this problem, the man who's going to outsmart Germany's most lethal weapon and save thousands of lives, isn't an admiral. He isn't a scientist. He isn't even an engineer. He's a 28-year-old cook who dropped out of school at 14. And in 6 weeks, he's going to prove that every expert in the Royal Navy has been wrong about something so fundamental, so obvious, that they'll wonder how they missed it for 3.5 years. This is the story of how observation defeated technology, how courage trumped credentials, and how one unauthorized idea changed the course of the Second World War. The ocean doesn't forgive mistakes. And in March 1943, the Atlantic Ocean has become a graveyard. March 17, 1943, 400 miles south of Iceland, where the water temperature hovers just above freezing and waves build to 15 feet, even on calm days. Convoy HX-229 struggles westward through the darkness. 41 merchant ships arranged in 9 columns, each vessel laden with cargo that Britain desperately needs. Steel, food, fuel, medicine, 140,000 tons of supplies that represent the difference between holding out for another month or beginning starvation rationing. Aboard the SS William Eustace, a Liberty ship positioned in the convoy's 4th column, 28-year-old Thomas "Tommy" Lawson stands in the galley washing dishes. The ship rolls violently as North Atlantic swells hammer the hull. Plates slide across the counter, pots clang against the stove. Everything that isn't secured becomes a projectile when the next wave hits. Lawson has learned to brace himself with his legs while keeping his hands free, a trick that took him 3 convoy runs to master. He's been at sea for 18 months now, ever since joining the U.S. Merchant Marine in September 1941. The pay is good, $125 a month, triple what he made working the breakfast shift at a diner in South Boston. But the money comes with a cost that nobody mentions in the recruitment posters. 1 in 26 merchant seamen won't make it home. Those are worse odds than being an infantryman, worse odds than being a bomber pilot. The only thing more dangerous than serving on a merchant ship is serving on a submarine, and even that's debatable. Above him on the bridge, Captain James Bannerman scans the horizon with binoculars. 52 years old, master mariner for 30 years, 3 convoy runs to Liverpool since America entered the war. Bannerman knows exactly what's waiting out there in the darkness. He's seen it before. The sudden explosion that turns a ship into a fireball, the screaming men jumping into water so cold it stops your heart in 4 minutes, the oil slicks that burn on the surface while survivors try to swim through them. He knows what's coming because everyone knows what's coming. The U-boats are out there. They're always out there. And they can hear everything. 600 yards off the convoy's port beam, beneath the surface where the waves don't matter. And the darkness is absolute. Kapitan Lieutenant Helmut Mansek sits in the control room of U-758. He's 29 years old, commanding his first patrol boat, and he's about to score his first confirmed kill. The hydrophone operator, a 19-year-old kid from Hamburg who looks even younger, presses his headphones tighter against his ears. His eyes are closed in concentration. "Contact," he whispers. "Bearing 280. Multiple screws. Heavy machinery noise." He pauses, counting the distinct sound signatures. "Estimate 40 vessels." Mansek smiles. This is why Germany is winning the Battle of the Atlantic. Not because their submarines are faster, not because their torpedoes are more powerful, but because their hydrophones can hear Allied convoy propellers from 80 nautical miles away. Individual merchant ships betray their position from 12 miles distant. Every turn of a propeller creates cavitation bubbles that collapse with a distinctive popping sound. Every diesel engine produces a rhythmic vibration signature. Every ship's hull resonates at a specific frequency based on its size and construction. The Allied convoys aren't just loud. They're announcing their exact position, their exact speed, their exact heading to every German submarine within listening range, and there's nothing they can do about it. Mansek plots his attack vector. U-758 will shadow the convoy for 6 hours, radioing position reports to the other submarines in Wolfpack Stürmer. 16 boats total, all converging on this single convoy. When darkness falls, they'll attack from multiple directions simultaneously. The convoy escorts, overwhelmed and outnumbered, won't be able to protect everyone. Some ships will die tonight. Many ships. What none of them know, not Captain Bannerman watching the horizon, not Capitan Lieutenant Mansek plotting his attack, not the 19-year-old hydrophone operator counting propeller sounds, is that the man washing dishes 3 decks below has noticed something. Something small, something everyone else has missed, something that's going to change everything. But we're getting ahead of ourselves. To understand how a cook solved a problem that baffled the best minds in naval engineering, we need to understand just how desperate the situation had become. The Royal Navy called it the U-boat peril. Prime Minister Winston Churchill, the man who'd stared down Hitler during the Battle of Britain without flinching, would later write in his memoirs that U-boats were the only thing that truly frightened him during the entire war. Not the Luftwaffe bombing London, not the threat of German invasion, not even the possibility of the Soviet Union falling. The U-boats. Because Britain is an island. Everything it needs, 2/3 of its food, 100% of its petroleum, 90% of its raw materials, arrives by ship. Cut those supply lines and Britain starves. Cut those supply lines and Britain's factories stop producing. Cut those supply lines and Britain surrenders without Germany firing a single shot at English soil. By March 1943, Germany is winning this war of attrition. The numbers tell a story that makes Allied naval commanders sick to their stomachs. In March alone, U-boats sink 567,000 tons of Allied shipping, more than any previous month of the war, more than Allied shipyards can replace. For 3 consecutive months, gross tonnage lost exceeds gross tonnage launched. The math is brutally simple. If this continues for 6 more months, Britain loses. Admiral Karl Dönitz, commander of Germany's U-boat fleet, has developed tactics that exploit every Allied weakness. His Wolfpack strategy positions submarines in patrol lines across known convoy routes. When one U-boat makes contact, it doesn't attack. It shadows the convoy and radios coordinates to every other submarine within range. Then they attack together from multiple directions, overwhelming the escorts. It's devastatingly effective. But here's the thing that keeps Allied commanders awake at night. The Wolfpack tactics only work because U-boats can hear convoys from so far away. German hydrophone technology is sophisticated, refined through 2 decades of development. A trained operator can distinguish between different types of ships based solely on their acoustic signatures. They can count the number of propeller blades by the frequency of cavitation sounds. They can estimate a ship's speed by the rhythm of engine vibrations. And Allied ships are loud, catastrophically loud. A Liberty ship, the workhorse of the merchant fleet, generates a sound profile that's detectable at 11.7 nautical miles. Its propeller, a massive 15-foot diameter bronze blade rotating at 76 revolutions per minute, creates cavitation bubbles that collapse with a distinctive popping sound audible for miles. Its diesel engine, producing 2,500 horsepower, vibrates the entire hull at specific frequencies. Its steam lines running throughout the ship create a resonance pattern that acts like an underwater beacon. Naval engineers understand the physics perfectly. Sound travels 4 times faster in water than in air. Sound waves in the ocean can propagate for hundreds of miles under the right conditions. Every piece of machinery aboard a ship creates vibrations. Those vibrations transfer through the hull into the water, and once in the water, those sound waves announce the ship's presence to anyone listening. The Allied navies have tried everything to counter this problem. In 1941, the Royal Navy installed ASDIC sonar on every escort vessel. ASDIC, the precursor to modern sonar, can detect submerged submarines at 2,500 yards. It's revolutionary technology and it works brilliantly, but it has one critical flaw. ASDIC can only detect submarines directly ahead of the escort vessel. The sonar beam creates a cone of detection, maybe 30 degrees wide. Any submarine attacking from the stern or beam which is exactly how Wolfpack tactics are designed, remains invisible. Worse, ASDIC is completely useless against surface submarines, and U-boats have learned to attack on the surface at night. Their low profile makes them nearly invisible to radar. Their electric motors, used for maneuvering, make them almost silent. They approach the convoy from upwind, so their diesel exhaust doesn't give them away, and they attack from the gaps between escort vessels, where there's no ASDIC coverage. In 1942, scientists at the Admiralty Research Laboratory developed high-frequency direction finding, nicknamed Huff-Duff. It's another brilliant innovation. Huff-Duff equipment can detect U-boat radio transmissions and triangulate their position with remarkable accuracy. Multiple escort vessels comparing Huff-Duff bearings can locate a submarine to within 5 nautical miles. It works so well that by late 1942, Huff-Duff stations have helped sink dozens of U-boats. But again, there's a limitation. Huff-Duff only works when submarines transmit radio signals, and once a Wolfpack achieves contact with a convoy, once they've positioned themselves for attack, they stop transmitting. They go radio silent. They just listen to the hydrophones and plot their attack vectors. All the Huff-Duff equipment in the world can't help if the enemy isn't broadcasting. By early 1943, the Allied Naval Command has invested what would be equivalent to $560 million in today's money, trying to solve the acoustic signature problem. The greatest minds in naval architecture, acoustic engineering, and submarine warfare have studied this challenge. Their conclusion is unanimous and depressing. You cannot make a merchant ship quiet enough to evade hydrophone detection. Professor Patrick Blackett, director of the Royal Navy's Operational Research Section and eventual Nobel Prize winner, publishes a classified paper in February 1943. His analysis is mathematically precise and utterly pessimistic. Merchant vessel propeller cavitation and machinery resonance create underwater sound profiles detectable at extreme range. Without fundamental hull redesign, impossible during wartime production schedules, convoys will continue to announce their positions to enemy hydrophones. There is no feasible solution. Dr. Harold Burris, the Admiralty's chief naval architect, explains the engineering reality in a memo dated February 14, 1943. The memo reads like a death sentence for Allied shipping. A Liberty ship's propeller displaces 2,500 tons of water per rotation through a 15-foot diameter blade. The resulting cavitation, the formation and collapse of vapor bubbles on blade surfaces, generates broadband acoustic energy across frequencies from 100 to 10,000 Hertz. German hydrophones are specifically optimized for this frequency range. Reducing propeller noise would require complete propulsion system redesign, new propellers with modified blade geometry, new engine mounts with vibration isolation, new hull construction techniques incorporating sound-dampening materials. Each modification would require 6 months of dry dock time per vessel and manufacturing capabilities we simply don't possess. Even if we had unlimited resources, which we don't, we couldn't retrofit the existing fleet before Britain runs out of supplies. The conclusion is inescapable. The merchant fleet will continue to be loud. U-boats will continue to hear them coming. Ships will continue to sink. And unless something changes dramatically, the Allies will lose the Battle of the Atlantic by autumn. The Atlantic Convoy Conference, held in London on March 4, 1943, brings together the highest-ranking naval officers from Britain, America, and Canada. The mood in the room is grim. These are men who've commanded fleets, who've won battles, who've sent thousands of sailors into harm's way, and now they're facing the possibility that they might lose the war not through any failure of courage or tactics, but through simple mathematics. The enemy can hear them. They can't make themselves quiet. The numbers don't lie. Rear Admiral Leonard Murray, commander of the Royal Canadian Navy's Atlantic Forces, delivers an assessment that silences the room. His voice is measured, professional, but there's an edge of desperation underneath. Gentlemen, we're losing. Our escorts can't hear the U-boats because of our own convoy noise. The enemy can hear us from 50 miles away. In March, at current loss rates, we're sinking faster than our shipyards can build. Unless we solve the acoustic detection problem, and I mean actually solve it, not just improve our odds marginally, we lose the Atlantic by summer. And if we lose the Atlantic, we lose the war. A British naval engineer proposes installing sound-dampening mounts on every piece of machinery aboard every merchant ship, rubber bushings, vibration isolators, acoustic insulation around engine spaces. It's a good idea, it would work. But the cost analysis is devastating. $250,000 per vessel with 12 weeks in dry dock. With 2,400 merchant ships in the Atlantic convoy system, it would take 138 years to retrofit the fleet. An American scientist suggests coating ship hulls with rubber to absorb sound waves, similar to how German U-boats use rubber coating to absorb ASDIC pings. Testing proves the concept works. In tank tests, rubber-coated hull sections show a 30% reduction in sound transmission. But field testing reveals catastrophic problems. The rubber degrades in salt water within weeks. It creates massive drag that reduces ship speed by 3 knots. And slower convoys mean more time at sea, which means more exposure to U-boat attacks. A Canadian engineer proposes redesigning propellers with swept-back blades to reduce cavitation, similar to modern aircraft propellers. The math checks out, the engineering is sound, and it's completely impossible to implement. It would require retooling every propeller foundry in North America, scrapping 14,000 existing propellers that cost $15,000 each, and halting Liberty ship production for 6 months while new manufacturing lines come online. By March 15, 1943, the assembled experts accept a grim reality. There is no technological solution to convoy acoustic signatures that can be implemented in time to matter. Merchant ships will continue to announce their positions to every U-boat within hearing range. The only strategy is to add more escorts, increase air cover, and accept that a certain percentage of ships won't make it. They're managing acceptable losses, not pursuing victory. The meeting adjourns with that bitter understanding. The best minds in Allied naval warfare have concluded that the problem is unsolvable. But 800 miles to the west, aboard a Liberty ship rolling through North Atlantic swells, a cook is about to prove them wrong. Thomas Patrick Lawson wasn't supposed to amount to much. Born in South Boston, Massachusetts in 1915, the son of Irish immigrants who'd arrived at Ellis Island with $8 and a cardboard suitcase. His father worked the docks. His mother took in laundry. Tommy was the youngest of 5 children, which meant hand-me-down clothes, shared bedrooms, and dinner portions that got smaller every time another mouth showed up at the table. He attended public school until age 14. Not because he was stupid. His teachers said he had a quick mind, good with numbers, curious about how things worked. But in 1929, the stock market crashed and the Depression hit South Boston like a sledgehammer. His father's dock work dried up. His mother's laundry clients couldn't afford to pay. The family needed money more than Tommy needed algebra. So he dropped out and found work at a diner in Dorchester, washing dishes for $6 a week. He was good at it, showed up on time, worked hard, didn't complain. After 2 years, they promoted him to line cook. After 4 years, he could work any station in the kitchen. Breakfast, lunch, dinner, short order, prep work, didn't matter. Give him a recipe and he'd learn it. Give him a problem and he'd figure it out. At 23, he got hired as a galley hand on a coastal freighter running between Boston and Charleston. The work was harder. The hours were longer. The ship stank of diesel fuel and old fish. But it paid $22 a week, more than triple what the diner offered. And Tommy Lawson had discovered something interesting about himself. He liked being at sea, liked the routine, liked the self-contained world of a ship where everything had a place and a purpose. When America entered the war in December 1941, merchant marine recruiters flooded the Boston waterfront. They needed experienced seamen desperately. Lawson signed up 2 weeks later, not out of patriotism, though he felt that too, but because merchant ships paid $125 a month. At 26 years old, it was more money than he'd ever imagined earning. His captain's evaluation from June 1942 tells you everything the Navy thought about Tommy Lawson. Lawson, TP, ship's cook, adequate performance, no leadership potential, recommended for galley duties only. Translation: he makes decent eggs, don't promote him. Nobody expected genius from the guy who served breakfast, but Tommy Lawson had developed a habit that the Navy evaluation didn't mention. He paid attention, not to the things he was supposed to pay attention to, the way every other sailor did. But to the things nobody else noticed, the small details, the patterns, the things that didn't quite fit. After the William Eustace survived 3 convoy runs to Liverpool, Lawson started spending his off-watch hours in places cooks aren't supposed to go. The engine room, the boiler room, the aft steering compartment. Places where the noise was deafening and the heat was brutal and you couldn't hear yourself think. The other crew members thought he was crazy. "Tommy's going to get himself killed down there," First Mate Robert Chen told the bosun. "That engine room is hot as hell and twice as loud. What's he doing? Sleeping on the steam lines?" But Lawson wasn't there for comfort. He was there because he'd noticed something during the last U-boat attack. Something about the way the ship sounded. Something about the way sound traveled through water. Something he couldn't quite articulate, but knew was important. February 19th, 1943. Mid-Atlantic, 400 miles from nowhere. The William Eustace is traveling in convoy SC-118, 63 ships in 9 columns, escorted by 4 corvettes and a destroyer. It's 3:15 in the morning. Most of the crew is asleep. Lawson is in the engine room during a U-boat alert, because this is apparently what he does now. Haunts the ship's mechanical spaces like a ghost. The ship's engineer, a gruff Scotsman named Donald MacLeod, who's been sailing for 30 years and has zero patience for cooks wandering into his domain, spots Lawson crouched near the main steam line with his hand pressed against the hull. "Get back to your galley, cook," MacLeod shouts over the roar of the turbines. "This is no place for the likes of you." Before Lawson can respond, the ship shudders. Not the normal roll of the waves. Something different. Something that travels through the hull like a shockwave. A torpedo has struck a vessel 2 columns over, the SS Robert Eden, a British freighter carrying steel and ammunition. Through the hull, through the vibration, traveling through water and steel, Lawson hears it. Not the explosion, though, that's loud enough to rattle his teeth. But what comes after? The water rushing into the dying ship's hull creates a strange, hollow, booming sound that resonates through the ocean like a drum. And then, as the Robert Eden's engine room floods, as water fills the compartments and drowns the machinery, the sound changes. It stops, not gradually, not fading away. It stops completely, like someone threw a switch. One moment, the Robert Eden is generating noise, machinery vibration, propeller cavitation. The next moment it's silent, acoustically invisible. Lawson grabs MacLeod's arm hard enough to make the engineer wince. "The sinking ship," Lawson says, his voice urgent. "It stopped making noise." "Of course it stopped," MacLeod yells, yanking his arm away. "It's full of water. Dead in the water. Dead. Period." Lawson struggles to explain something he barely understands himself. When the water flooded the hull, it stopped the machinery vibration. The U-boats can't hear it anymore because the water dampened the sound. The water absorbed the vibration. MacLeod stares at him like he's lost his mind. "So, what if we could flood parts of our ship on purpose? Not enough to sink us, just enough to silence the machinery noise. Water-filled chambers around the propeller shaft. Ballast tanks positioned against the engine mounts. Controlled flooding systems that create acoustic barriers." MacLeod's expression shifts from confusion to something close to anger. "That's the stupidest thing I've ever heard. Water inside a ship is called sinking. You're a cook. Stick to cooking." But the idea won't leave Lawson alone. For 2 weeks, as the William Eustace makes the crossing to Liverpool, he sketches diagrams in a notebook during his off-watch hours. Water-filled chambers, acoustic dampening systems, ways to position water as a barrier between machinery and ocean. He shows the sketches to MacLeod, who dismisses them without a second look. He shows them to First Mate Chen, who laughs and says, "Tommy, you've been at sea too long." He shows them to Captain Bannerman, who sighs with the patience of a man who's had to deal with 1,000 terrible ideas from well-meaning crew members. "Son," Bannerman says gently, "I appreciate your initiative. Really, I do. But leave the engineering to the engineers. You've got a good berth here. Don't complicate it with ideas above your station." Above your station. That phrase, Tommy Lawson has heard it his entire life, from teachers who said college wasn't for kids like him, from bosses who said management positions weren't for high school dropouts, from every person who'd ever looked at his background and decided his ceiling was already visible. Nobody takes the cook seriously. Which is exactly why what happens next is so important. March 24, 1943. The William Eustace docks in Liverpool after a convoy run that lost 11 ships to U-boats. Lawson has 48 hours of shore leave before the next departure. Most sailors head to the pubs. Some find lodging houses for a proper night's sleep in a bed that doesn't move. A few visit the churches to pray for better luck on the next crossing. Tommy Lawson does something that could get him arrested for espionage, court-martialed for insubordination, or at minimum, thrown off his ship and blacklisted from merchant service. He walks into the Western Approaches Command headquarters, a fortified building called Derby House, that serves as the nerve centre for Britain's Atlantic convoy operations, and asks to speak to someone about U-boats. He doesn't get to see an admiral. He gets arrested. 2 Royal Navy Shore Patrol officers intercept him in the lobby before he makes it 10 feet past the entrance. They're both over 6 feet tall, both built like brick walls, and neither looks pleased to see an American merchant seaman wandering into a restricted military facility. "You can't be here, mate," one of them says, grabbing Lawson's arm with enough force to leave bruises. "This is a restricted area. What ship are you off?" "William Eustace," Lawson says, trying to stay calm. "I need to talk to someone about convoy noise. I have an idea about acoustic dampening that could—" "Everyone's got ideas, Yank. Now clear off before we throw you in the stockade for unauthorized access." They're physically escorting him toward the door, one on each arm, when a voice calls from across the lobby. "Wait." The speaker is Commander Peter Gretton, 29 years old, one of the most experienced escort group commanders in the Royal Navy. He's just returned from convoy ONS-5, an 8-day nightmare where he lost 13 merchant ships despite his best efforts. He hasn't slept in 36 hours. He's frustrated, exhausted, and desperate for any advantage against the U-boats that keep slaughtering his convoys. "What did you say about convoy noise?" Gretton asks, walking over. The shore patrol officers look uncertain. Gretton might be young, but he's got 2 distinguished service crosses and a reputation for accepting nothing less than perfection from his crews. When he asks a question, people answer, Lawson explains quickly. The sinking ship going silent, the concept of water dampening machinery vibration, the idea of controlled flooding to create acoustic barriers. He pulls out his notebook, shows the sketches, explains his theory about positioning water-filled chambers around propeller shafts and engine mounts. Gretton listens with his arms crossed. When Lawson finishes, the commander says 5 words that should have ended the conversation right there. "That's the most ridiculous thing I've heard this month." But then he pauses. His eyes narrow. His head tilts slightly, the way people's heads tilt when they're reconsidering something they just dismissed. "Water inside a ship is called sinking," Gretton says slowly. "Not if you control it," Lawson responds. "Small sealed chambers, positioned strategically. You're not flooding the whole ship, you're creating acoustic insulation." "Acoustic insulation," Gretton repeats the phrase like he's testing how it sounds, like he's trying to figure out if this American cook is crazy or brilliant or both. "Water absorbs vibration better than air," Lawson continues, sensing an opening. "If you position water-filled chambers against machinery, between the noise source and the ocean, you create a barrier. The sound has to pass through water before it reaches the hull, and water dampens sound. That's just physics. I know what acoustic insulation is." Gretton's expression changes. Something shifts behind his eyes. A calculation, a possibility, a willingness to consider that maybe, just maybe, every expert has been looking at this problem from the wrong angle. "Come with me," Gretton says. The shore patrol officers release Lawson's arms. Gretton leads him deeper into Derby House, past checkpoints where guards salute the commander, and eye the American merchant seaman with obvious suspicion. They end up in a small office cluttered with charts, reports, and convoy tracking maps, marked with red X's showing ship losses. "Here's the problem," Gretton says, spreading a map across his desk. "Every expert, every scientist, every engineer has told us that making ships quieter requires complete redesign. New propellers, new engine mounts, new hull construction, all of which is impossible during wartime. But what if—" He trails off, staring at Lawson's notebook sketches. "What if the solution isn't redesigning the ships?" Lawson finishes the thought. "What if it's just changing what's between the machinery and the ocean, not air, water?" Gretton runs his hand through his hair. "If this works, And that's a massive if. But if it works, we test it quietly. Unofficially. No one needs to know until we prove it's not completely insane. Over the next 3 days, something extraordinary happens. Commander Gretton, a Royal Navy officer who should be following proper channels and getting approval from the Admiralty, instead conspires with an American merchant cook to conduct an unauthorized experiment on a British warship. They choose HMS Sunflower, a Flower-class corvette currently in dry dock at Liverpool for routine maintenance. Gretton has friends on the corvette's crew. The captain owes him a favor. More importantly, Sunflower is small enough that modifications can be made quickly and quietly. Lawson, Gretton and the Sunflower's engineer, Lieutenant James Whitby, spend 3 days jury-rigging a prototype system. They weld empty oil drums around the corvette's propeller shaft housing. They position them strategically, creating water-filled chambers between the shaft bearings and the hull. They add sandbags to simulate water weight against the engine mounts. It's crude, it's ugly, and according to every regulation in the Royal Navy manual, it's completely unauthorized. If anyone in the Admiralty finds out, Gretton's career is over. Whitby would face court-martial, and Lawson would be deported back to America with a black mark on his record. But they do it anyway, because sometimes desperation makes you brave. Sometimes desperation makes you willing to risk everything on a cook's crazy idea. March 28, 1943. First test. Sunflower motors out into the Mersey River at low speed. HMS Trespasser, a submarine participating in this unauthorized experiment, submerges 500 yards away with hydrophones active. Lawson stands on Sunflower's deck, hands gripping the railing so hard his knuckles turn white. Everything depends on the next few minutes. Trespasser surfaces, signals, heard you clear as day, engine noise, propeller cavitation, same as always, failure. Told you it was bloody stupid, Whitby mutters. But Lawson has noticed something. The oil drums they welded around the propeller shaft, they're not full anymore. They were filled when the ship was in dry dock, but now, after an hour of operation, they've drained through the seams. The water they thought was creating acoustic barriers has leaked out. We need to seal them, Lawson says. Make them completely watertight. The concept is right. We just didn't execute it properly. Gretton runs his hand through his hair, a nervous habit Lawson is beginning to recognize. If the Admiralty finds out I'm modifying a warship without authorization, I'll be court-martialed. If they find out I'm doing it based on a merchant cook's theory, I'll be committed to an asylum. If the Admiralty finds out U-boats are sinking 20 ships a week because we're too proud to test a cook's idea, Lawson says quietly, we lose the war. The words hang in the air. Gretton stares at Lawson for a long moment. Then he nods. 3 more days. Then this experiment ends. They work around the clock. They weld sealed steel chambers. They add water-filled rubber bladders against engine mounts and steamline supports. They create what naval engineers will later call liquid acoustic dampening, though at the time they're just 3 desperate men welding metal and hoping physics works the way a cook thinks it should. April 2nd, 1943. Second test. Sunflower motors at full speed, engines at maximum output, propeller churning. Trespasser submerges 1,000 yards away, farther than the first test, with hydrophones at maximum sensitivity. Minutes pass. No signal from the submarine. More minutes pass. Still nothing. Sunflower continues on course. 5 minutes, 10 minutes, 15 minutes. Finally, Trespasser surfaces. The submarine captain, a veteran named Harris, who's been operating hydrophones since 1940, signals a message that makes Lawson's legs go weak. Lost you at 400 yards. Hydrophones picked up nothing but ambient ocean noise. Gretton's face goes white. Say that again. Harris repeats the message. Lawson closes his eyes. His hands are shaking. It works. Commander Gretton requests an emergency meeting with Rear Admiral Max Horton, Commander-in-Chief of Western Approaches. It's an audacious move. Junior officers don't request emergency meetings with admirals unless someone is dying or the war is ending. Gretton brings Lawson, which horrifies the admiral's staff. A merchant cook in the Admiralty boardroom. It's unprecedented. It's inappropriate. Admiral Horton, a legendary submariner from World War I who understands underwater acoustics better than anyone in the Royal Navy. enters the boardroom with 3 other senior officers and Dr. Harold Burris, the same naval architect who declared acoustic dampening impossible. Hydrophone detection range reduced from 12 miles to 400 yards. "This is preposterous," Dr. Burris snaps. "You've conducted unauthorized modifications to a Royal Navy vessel based on the suggestion of a cook who understands acoustics better than your entire department," Gretton fires back. "Commander, you're out of line," Captain Edmund Rushbrook, Director of Naval Intelligence, barks. "Compromise what?" Gretton interrupts. The sarcasm hangs in the air like a challenge. "You don't speak to senior captains that way. Not if you value your career. He's pulled too many men out of oil-slicked water. He's written too many letters to widows." "Explain it to me," Horton says, looking at Lawson. Lawson stands. Every eye in the room focuses on him. The American merchant cook in a room full of British naval royalty. That these men have university degrees, decades of experience, commands that include thousands of sailors. And here he is, explaining physics to admirals. That vibration travels through the hull into the water. The ocean carries that sound for miles, but water absorbs vibration better than air or steel. If you position water-filled chambers around propeller shafts and engine mounts, you create barriers that prevent sound from reaching the ocean. It's not complex engineering. It's just using the ocean's own properties against itself. Water inside a ship's structure creates weight distribution problems. Water in sealed chambers, Lawson corrects, positioned specifically for acoustic dampening. One test, Burris scoffs. Under controlled conditions, in a river, with a friendly submarine. Captain Rushbrook throws his hands up. "Admiral, you can't be serious. This would require modifying hundreds of ships, diverting dockyard resources, based on test results," Gretton interrupts. "Based on the fact that in March, we lost 567,000 tons of shipping because U-boats heard us coming. Based on the fact that if we don't do something different, we lose this war by autumn. The experts have all said the problem is unsolvable. Admiral, even if this concept has merit, and I'm not conceding that it does, implementation is impossible. We'd need to retrofit 2,400 merchant ships. The dockyards are at maximum capacity. Steel is needed for escort vessels and new construction. We're looking at a minimum of 6 weeks per ship, which means..." Every head turns toward him. It's not complex engineering, and you don't need to retrofit every ship immediately. Just enough to test it in actual convoy operations. What Lawson is proposing is insane, gambling that a cook's observation is more accurate than years of expert analysis. If we divert resources to this experiment, and it doesn't work in combat conditions, we've wasted weeks we don't have. "If we don't test it," Gretton says, his voice hard, "we've already lost." The Admiral walks to the window, staring out at the Thames River, at the city that's been bombed for 3 years, at the docks where merchant ships unload what little cargo makes it through the U-boat gauntlet. "Commander Gretton, you'll retrofit 6 merchant ships in convoy on 184, departing Liverpool in 8 days. Dr. Burris, you'll provide technical support even if you think this is insane." He looks at Gretton. "You'll spend the rest of the war commanding a minesweeper in the Orkney Islands." Horton looks at Lawson. "Mr. Lawson, I don't know if you're a genius or a madman. The die is cast, the experiment is approved, and in 8 days they'll find out if a cook's observation can save the Battle of the Atlantic." The most intense week of Tommy Lawson's life begins with a briefing to 6 merchant ship captains, who are informed that their vessels will undergo experimental modifications based on unproven acoustic theory developed by a cook. "You want to fill my ship with water?" Captain Morrison of the SS Daniel Webster asks. "Have you lost your mind?" "Sealed chambers," Lawson explains for what feels like the 100th time. "Positioned around propeller shafts and engine mounts, not flooding your ship, creating acoustic barriers. And if these chambers rupture at sea, if they spring leaks, if they shift our weight distribution and make us unstable in heavy weather?" These are good questions, reasonable questions. Questions that make Lawson's stomach twist because he doesn't have perfect answers. He has theory. He has one successful test. He has the desperate hope that physics works the way he thinks it does. "The chambers are welded steel," he says, "structurally sound, tested to withstand more pressure than they'll experience in any operational conditions. As for weight distribution, we're adding 18 tons total. Liberty ships are designed to carry 9,000 tons of cargo. 18 tons is statistically negligible. Statistically negligible, Captain Morrison repeats. That's reassuring. My ship, my crew relying on statistics from a cook. The work begins anyway because Admiral Horton gave an order, and you don't argue with admirals. Dockyard crews work around the clock. Welders fabricate cylindrical steel chambers 24 inches in diameter. Fitters position them around propeller shaft housings. Engineers install water-filled rubber bladders against engine mounts and steam line supports. The installation is brutally simple. No complex machinery. No sophisticated instruments. Just steel, water, and strategic positioning. Total added weight per ship, 18 tons. Total installation time, 64 hours per vessel. Naval engineers supervising the work are deeply skeptical. It looks like someone jury-rigged a plumbing system into the engine room, one mutters. He's not wrong. It does look improvised. It looks exactly like what it is. A cook's idea implemented by desperate men willing to try anything. But the hydrophone tests are undeniable. Trespasser conducts acoustic measurements on each modified ship. Before modification, Liberty ship acoustic signature detectable at 11.7 nautical miles. After modification, 0.4 miles. The ships have become 29 times quieter. April 22, 1943. Convoy on 184 departs Liverpool. 43 merchant ships in 9 columns, escorted by 6 corvettes and 2 destroyers. The 6 modified ships are spread throughout the formation, 2 in the starboard columns, 2 port, 2 center. Nobody has told the convoy commodore about the experiment. If U-boats attack, and they will attack because they always attack, the test happens under real combat conditions. No controlled environment, no friendly submarines, just the Atlantic Ocean and German wolf packs and the question of whether water-filled chambers will actually keep ships alive. German naval intelligence has tracked the convoy departure. 37 U-boats, Group Miser, deploy in patrol lines across the expected route. Kapitan-Leutnants receive their orders. Find the convoy. Shadow it. Radio coordinates. Attack at night. April 25, 1943. Mid-Atlantic, 200 miles from nowhere. 2:14 in the morning. Aboard U-264, Kapitan-Leutnant Hartwig Lux studies his charts. His hydrophone operator has been tracking convoy sounds for 6 hours. Contact weakening, Herr Callot, the operator reports. Original bearing 290, but signal intermittent. Some ships very loud, some almost silent. Lux frowns. Intermittent. That's impossible. Either you hear a convoy or you don't. Convoys are loud. They're always loud. They announce their presence like underwater beacons. That's why wolf pack tactics work. Jawohl, Herr Callot, but I'm tracking multiple signatures. Some ships clear at 40 kilometers. Others disappear at 5 kilometers. This makes no sense. Lux orders U-264 to periscope depth. Through the scope, he sees the convoy. 9 columns, maybe 40 ships, ploughing westward. But something is wrong. His hydrophones should be hearing all of them. Instead, he's only tracking 27 distinct acoustic signatures. 16 ships are missing from his hydrophone plot, not because they're not there. He can see them through the periscope, but acoustically they've disappeared. No, not 16. 6. The other 10 are simply too distant for reliable hydrophone detection. But 6 ships scattered throughout the convoy formation are generating no acoustic signature whatsoever. They're as quiet as submarines, quieter than submarines. Lux makes a decision that will save Allied lives, but doom his own U-boat. He targets only the ships he can hear clearly. The modified vessels, quieter than the surrounding ocean, slip past his attack position undetected. Over the next 18 hours, Wolfpack Group Miser achieves multiple contacts with convoy on 184. It becomes a running battle. U-boats attacking from stern and beam, escort vessels dropping depth charges, star shells turning night into day, torpedoes tracking toward merchant ships that zigzag desperately. 9 ships sink. SS Rotterdam, SS Empire Defender, SS Pacific Star, SS North Britain, SS Nariva, SS Fort Rampart, SS Brinkburn, SS Shillong, SS Zeeland. 3,200 men in lifeboats or swimming through oil-slicked water that's cold enough to stop your heart in 4 minutes. 47,000 tons of cargo settling to the ocean floor 3 miles down. Hey, it's a brutal loss, a devastating loss. Captains dead, engineers dead, radio operators and deckhands and ordinary seamen dead. Men who'll never see their families again because a German torpedo found them in the darkness. But here's the critical statistic that makes this battle different from every other convoy engagement. Of the 9 ships sunk, 0 are modified vessels. SS James, Herod, survives. SS John Davenport, survives. SS Samuel Elliott, survives. SS Benjamin King, survives. SS William Eustace, survives. The 6 ships with Lawson's acoustic dampening system passed through a Wolfpack engagement without a single torpedo fired at them. U-boats attack the loud ships, the normal ships, the ships that announce their presence with every turn of their propellers. The modified ships, acoustically invisible, survive untouched. May 7th, 1943. Convoy On 184 reaches New York Harbor. Commander Gretton, who accompanied the convoy aboard the destroyer HMS Vannock, immediately signals London. Modified vessels showed 0 enemy engagement, despite comparable positions within convoy formation. Acoustic dampening effective under combat conditions. Recommend immediate fleet-wide implementation. The news reaches Admiral Horton within hours. He reads the signal 3 times, then summons his staff. "Gentlemen," he says, "the cook was right. Begin retrofit operations on the entire fleet." May 12, 1943. Admiralty Statistical Analysis. The Western Approaches Command runs the numbers. They compare March convoy losses before acoustic dampening with May convoy losses after widespread implementation. The statistics are staggering. March 1943, before acoustic dampening, average U-boat detection range, 11.4 nautical miles. Convoy ships sunk per Wolfpack engagement, 31% loss rate. U-boats lost per convoy engagement, 1.2 submarines. May through July 1943, after acoustic dampening, average U-boat detection range 0.6 nautical miles. Convoy ships sunk per Wolfpack engagement, 4.7% loss rate. U-boats lost per convoy engagement, 4.8 submarines. Read those numbers again. Acoustic dampening reduces ship losses by 85%, while U-boat losses increase 400%. U-boats that previously detected convoys from 50 miles away now have to approach within half a mile. That brings them into ASTIC range, into radar range, into visual range. Suddenly, all the defensive systems that couldn't protect convoys before work brilliantly, because the escorts can actually find the submarines before they attack. Wolfpack tactics collapse, because submarines can't coordinate attacks on targets they can't hear. They can't achieve perfect firing positions when they have to get close enough that escorts detect them first.